We will focus today on functions, which is from discrete mathematical structures. The subject is in second year computer science and information technology. In the previous video, we have defined what is function, what are the constraints of the function, how relation can be a function if it satisfies two conditions that we have seen, and we have seen what are the different types of function. So, in this video we will focus on one of the type of function, that is into function. Okay, we will see one by one. Let us go to the next slide. The learning outcome. At the end of this video session, student will be able to distinguish, or he will be able to identify the type of the function, whether it is onto or into or some other type of function. The content of this particular video, first of all, will review what are the types of function, then we will define what is into function, and then we will go for examples on into function. Basically, as I told you that there are four types of function. The first one is called as a onto function. The second one is called as a into function, and onto function is also called as surjective function. And into function, then we have third, that is called as a one-to-one, or it is also called as a injective function, then one-to-one onto function, and that is also called as a bijective function. So, basically there are four types of function. In the previous video we have seen what is onto function. Okay, I will just take to the next slide. We will see what is, just review what is onto function. For a definition, for function f from x set x to set y can be called as onto function if the range of the function is y. Okay. If the range of the function is y, that is Rf, if suppose that is equal to set y, okay, then it should not be subset of y, then it is called as a onto function. Then it is called as a onto function. Now, what will be the into function? Okay, that we will see in the next slide. Now, definition of this into function. Here it is defined a mapping of function f from set x to set y, which is called into function if the range of the function is subset of y. Now, look at the difference between onto function and the into function. Onto function, the definition was the range of the function should be equal to y, whereas in into function the range of the function should be subset of y. Means that in general, okay, if suppose the range of the function is equal to say set y, then it is called as onto, otherwise it is called as a into function. Means if it is not equal to set y, okay, if suppose it is a subset of y, okay, then it is called as a into function. That is, a range of function is subset of y, where x and y are nothing but the sets. Now, let us see examples. Example number 1 on the into function. And now, consider the example where set x is equal to say the elements are say x1, x2, x3 and x4. 4 elements are there, and in set y, say we have y1, y2, y3 and y4. That is 4 elements in set y. And the function, how it is defined? It is defined and it is given f is equal to such that there is a mapping from set x to set y. Okay, that is equal to mapping. First mapping is x1 to y1, second one is x2 to y3, and third one is x3 to y2, and fourth one is x4 to y3. Okay. Now, let us explain on the table. Okay, in the table f x to y is given. How is the mapping? x1 to y1, this is the first set, then x2 to y3, this is the second set, and the third is arrow, Third mapping is say x3 to y2, and fourth mapping is x4 to y3, x4 to y3. Now, if you look at this particular mapping, okay, now whether it is onto function or into function, okay, before that whether it is a function or not, okay, the first two conditions for the function, the domain of the function should be equal to set x. Okay, means all the elements of set x should be mapped to some elements of y. Some elements of y means x1 is mapped to y1, then x2 is mapped to y3, and x3 is also mapped to y2, and x4 is also mapped to some element of y. Okay, the second condition was whether uniqueness of mapping, uniqueness means every x should have unique value of y. Every x should have unique value of y, means x1 f of, if you take f of x1, that is equal to y1. Okay, it shouldn't have two values of y. Okay, that is the second condition. So that is also satisfying over here, because f of x1 is equal to y1, only one value is assigned. F of x2 is also assigned y3 only, and f of x3 is assigned only one value, that is y2, and f of x4 is assigned only y3. So this is how means definitely it's a function, no doubt about that, whether it is onto function or into function. As per the definition, the range of the function f should be equal to subset of y. Now, what is the range of the function? Now, if you look at the values of y, how many values of y are actually involved in the mapping? If you look at this particular table, so we see that y1 is involved, y2 is involved, and y3 is involved, and y4 is not involved. Means if you take the range of the function f, that is equal to y1, y2, and y3, only three values, means that definitely it is not equal to entire value of set y. Okay, so it is a subset of y. Let us go to the next slide. Domain of the function, that is range, domain of the function as we have given, that is x1 to x4, and the range of the function is equal to y1, y2, and y3, which is definitely subset of y. Hence, it is called as a into function. Now, let us go to the next slide. Consider the example number 2. Okay. Now, here x is equal to, the values are a, b, c, and y is equal to say 0, 1, 2. These three values are there in y, and three values are there in set x. And the mapping function g is equal to such that x to y such that a0, b0, and c1. a to 0, b to 0, and c to 1. Whether it is a valid function? Yes. First of all, domain of the function is equal to ABC, means all the elements of x are involved in the mapping. They have some value of y, and the uniqueness of means every x should have unique value of y. That is, a is assigned to 0, b is assigned to 0, and c is assigned to 1. There is no element in x that it has assigned two values of y. So that's why it's a valid function. Now, if you look at the range of the function, okay, that is equal to, we have to consider the elements of y which are involved in the mapping of G. Now, the elements involved in the mapping are 0 and 1. Okay, the element 2 is not involved because there is no arrow from set x to set y to the element 2. Okay, only 0 and 1 are involved in the mapping. It does mean that the range of the function is equal to 0 and 1. The range of the function is equal to 0 and 1. It does mean that it is a subset of y, it is not equal to y. So, if you look at the definition, if you recall the definition is for into function is that the range of the function should be equal to subset of y. It should not be equal to set y. If it is set equal to set y, then it is called as onto function. Now, looking at this example, it is equal to 0 1, which is subset of 0 1 2, or which is subset of set y. So, hence it is called as into function. Now, the same thing is mentioned over here in the next slide. The range of the function, that is RF is equal to 0 1, okay, which is subset of y, hence it is called the into function. Hence it is called the into function. Now, let us go to the next slide. Now, here I will give one example, okay, for you. You have to take a minute and take a piece of paper and identify the type of the function. The example 1, what is given here, let suppose x is equal to, the values are 1, 5, p and jack, and say y is equal to 2, 5, 7, q and jill, okay, and the mapping or the function f is equal to, how it is mapped like this, from set x 1 to 2, from set x 5 to 7, then p to q, that is x y, p to q, and then we have jack and jill. These are the mappings from set x to set y. Now, take a minute and identify it. Let us go to the next slide. The answer of this particular function or the mapping is like this: 1 to 2, 5 to 7, p to q and jack and jill. The answer for this particular mapping or the identification or which is the type of the function, the answer for this is the range. Now, first of all, we need to identify the range of the function. Okay, range of the function f is equal to 2, 7, q and jill, which is subset of y. So, hence it is a into function. Hence it is a into function. It is not a onto function. So, this is all about into function. Now, we will see one more type of function in the next video. Okay. The references are as given below, and I hope you understood it. Thank you very much.